Hi, everyone. We would like to talk to you about the challenges we are trying to address on sample collection and laboratory procedures for measles biological confirmation and seroprevalence. While case confirmations is most of the time not necessary for case management decisions, the measles outbreak response relies on the timely biological confirmation of outbreaks to facilitate a vaccination response. But in MSF settings, most of the time in remote areas with limited lab capacities, we may experience delays in outbreak confirmation. On the other hand, seroprevalence estimates are necessary because of unknown real immunization level of the population due to unreliable vaccination status and disease history. Seroprevalence estimate can help plan vaccination activities by identifying pockets of low immunity. In addition, seroprevalence can help evaluate our vaccination activities. We can quantify if immunization levels in the population are sufficient to prevent epidemics. And we can also quantify if we are really targeting so far non-immunized children. To answer those questions in our context, we ideally need to use blood samples that are easy to collect without invasive procedures, easy to transport, meaning stable in time and high temperature, and we need a laboratory that performs reliable and accessible serology assays. If we want to biologically confirm cases of measles, the serology assays are based on IgM detection that increase shortly after the onset of symptoms. IgG antibodies gradually increase and become detectable for several years after infection. And IgG are also the antibodies that increase after vaccination. So IgG detection is used to estimate seroprevalence, either after natural measles infection or vaccination. For us, serology assays present the same challenges, regardless of the type of antibodies they detect. Concerning these challenges on the type of samples, the WHO recommends serum or plasma as reference samples, but they have practical limitations. Concerning the type of assays, the reference method is neutralization, but this method is only applicable in highly advanced laboratories. So we need to investigate more acceptable alternative methods. Dry blood spot taken from a fingerprint is the most convenient sample, easier to collect and to transport at room temperature. But it doesn't seem so simple in practice, mostly related to the increased stability in field conditions and the lack of standardization. ELISA is the most accessible method in our interventions context, but lacks some standardization regarding the positivity threshold, the adjustment factor needed when we use DBS, and the correlation with seroprotection. So now, based on example of studies, we are going to discuss some of these challenges that we are facing with DBS and ELISA, and how we try to address them.
So for the biological confirmation of measles cases, WHO recommends the use of DBS samples where serum cannot be used. However, the performance of DBS may be worse due to the impact of environmental conditions on sample preservation. So we therefore decided to evaluate the performance of DBS samples under field conditions in the DRC. Suspected measles cases were invited to provide paired samples of DBS and plasma. The samples were transported to the laboratory using the regular transport mechanisms, where DBS were shipped at room temperature and plasma at 4 degrees. Both sample types were analyzed using a semi-quantitative IgM ELISA. So here you can see the preliminary results of 148 participants. So while 53% of the participants were diagnosed positive for measles based on plasma, only 42% of participants were diagnosed positive based on DBS. So this means that DBS had a sensitivity compared to plasma of 84%, so meaning among participants diagnosed positive based on plasma, only 84% would have been diagnosed based on DBS samples. So when looking at the sensitivity of DBS over shipment delay, you can see that the DBS sensitivity decreases the longer it takes for the samples to arrive in the laboratory. Moreover, we can also see an impact of the sample location, where areas that are difficult to access have a lower sensitivity of 72% compared to 95% in easy accessible locations. So as there is a correlation between the type of location and the sampling and the shipment delay, it is not possible to differentiate between the conditions at the moment of sampling and the delay and the impact on the sensitivity based on these results. So in summary, we can say that for the timely and efficient confirmation of outbreaks, DBS samples can be used if they can be shipped to the laboratory within a few days. So unfortunately, this means that DBS is not the solution to all of our problems. However, we will evaluate whether the performance of DBS can be improved when shipping the samples at 4 degrees. Now moving on to the challenges we are facing for the interpretation of ELISA-based seroprevalence results. So here I will present the results of a study that was implemented to quantify the proportion of already immunized children at MSF vaccination sites during a preventive measles vaccination campaign in the DRC. So children were invited to provide a DBS sample and were also asked to answer a short questionnaire about vaccination history and history of previous measles infections. The samples were analyzed using a semi-quantitative IgG ELISA. Surprisingly, the seroprevalence was below 40% compared to reported vaccination of 87%, which may also be inaccurate. So the lower than expected seroprevalence raised the question whether the recommended threshold of IgG levels actually allowed to correctly identify immunized individuals. Moreover, we found no association between the reported vaccination status and the seroprevalence, where you can see here children with reported vaccination in dark blue and those without reported vaccination in light blue. And so this raises the question whether ELISA-based seroprevalence is indicative of protection for future infections on measles. So here we only use DBS samples. So we also are wondering whether these seroprevalence estimates based on DBS samples will need to be adjusted to match to the reference, the serum-based estimates.
And that's why, in another survey, we studied the impact of sample type on seroprevalence estimates. We wonder whether the quality of DBS under field conditions is comparable with DBS under laboratory conditions and serum. We carried out a seroprevalence study in the Dender region in Niger, and we collected different samples among a subset of 156 children. 1 DBS obtained at home and stored at room temperature, 1 DBS performed in the laboratory from a whole blood tube, and 1 serum sample stored at -20 degrees. And we performed quantitative ELISA on these 3 samples in the same conditions. To the question, do DBS carried out on site under field conditions give similar results to DBS prepared and stored under lab conditions? The answer is yes. There is no significant difference in seroprevalence estimates given by both types of DBS. To the question, do DBS carrying on under field condition give similar result to DBS prepared compared to serum? The answer is now no. It seems that the DBS overestimate the seroprevalence since we consider the serum results as the reference. And serum sample give a seroprevalence estimated at around 50%, while reported measles vaccination or infection is estimated at 88%. So here as well, the seroprevalence is lower than expected, and we will discuss that later. To be able to estimate the seroprevalence from DBS results, we expected to have to estimate an adjustment factor. And that would enable us to estimate a seroprevalence closer to that obtained with the serum, the reference samples. So here are the seroprevalence estimated from DBS results after proportional adjustment to the serum results. So we confirm here it is necessary to validate the DBS methods against serum to get the adjustment factor or optimize the lab methods to provide the best correlation between both samples.
Okay, so in summary, for the use of seroprevalence for the planning and evaluation of vaccination activities, we can say that DBS is usable under few conditions. However, adjustment factors will be required. So we need to also evaluate whether these adjustment factors are consistent across settings or need to be re-evaluated in different settings. However, it is important to point out that the seroprevalence estimates based on ELISA, both based on DBS and serum sample, were much lower than expected. So this means that in the moment we can use ELISA-based estimates to compare between different settings, but probably we cannot rely on the absolute estimates. So before using ELISA-based seroprevalence to inform operational decisions, we'll need to evaluate whether these estimates are actually a good indicator of protection. So in conclusion, when evaluating the different alternatives for types of samples and types of assays, we can say that DBS is an appropriate sample type, both for the confirmation of outbreaks and for seroprevalence, if a quick transport to the laboratory can be guaranteed. For the use of ELISA-based seroprevalence estimates, we'll need to better understand the interpretation of ELISA results themselves before being able to use them really for operational decisions. And then finally, we will also need to evaluate how much precision is actually needed. So while efficient outbreak confirmation can be based on imperfect test results, seroprevalence estimates need to be more accurate to evaluate and plan vaccination activities. So we would like to thank all the teams involved in the DRC and the Niger surveys, and thank you very much for your attention.